Children, today we are going to discuss about rational numbers. Before going to start 8th standard first chapter rational numbers, let us discuss about a number system. So in the number system, if you consider the first set, that is set of natural numbers. What do you mean by natural numbers? The counting numbers are called what? Natural numbers. So natural numbers starts from 1, 2, 3, 4 and so on. These numbers are called natural numbers denoted by the letter n. Next, if we consider the next set, that is set of whole numbers. So set of natural numbers including whole numbers is called whole numbers. That is set of natural numbers including 0 are called whole numbers. That is 0, 1, 2, 3 and so on are called whole numbers. Next, the next set is integers. Integers also denoted by z, nothing but zil numbers. So zil numbers which is equal to the -3, -2, -1, 0, 1, 2, 3 and so on. If you observe in the set of integers, there exists some positive numbers and negative numbers and 0, including 0. So set of positive, negative, including 0 is called what? Integers. Right? Next set, if you observe, that is rational numbers. So rational numbers is the set of numbers which are in the form of p by q, where p, q belongs to integers and q not equal to 0. Right? Today we are going to discuss this chapter and operations on these rational numbers. So some properties based on rational numbers we are going to discuss. Here if you observe, natural number is subset of whole numbers. Whole numbers is subset of integers. All the integers also subset of rational numbers. That means all the natural numbers also exist in whole numbers. All set of whole numbers also exist in integers. Set of all integers also can be written in the form of p by q except q not equal to 0. That means all these numbers also exist in set of rational numbers. Brief definition of rational numbers. The set of numbers which can be written in the form of p by q are called rational numbers, where p, q belongs to integers and the condition is what? Q must not equal to 0. If denominator is 0, which cannot be defined, so that denominator condition must be mentioned that as not equal to 0. So set of rational numbers generally denoted by q. Why? Because we can also call these rational numbers as quotient numbers. Every p by q form of a number gives a certain quotient. So what is the starting letter of quotient here? Q. That's what rational numbers denoted by the letter q. So what is the general form here? P by q, where p, q belongs to integers and q not equal to 0. Right? This is the definition of the rational numbers. For example, if you consider the numbers p equal to 2, q equal to 3. So 2 by 3 is a example of rational number. 5 by 7. We can consider negative numbers also, -5 by 7, right? 0 by any number also nothing but 0. We can also write in this way. But 1 by 0 or 5 by 0, like that we do not write. Q must not be equal to 0. So that Q must not be written in the form of 0. We can take in the numerator, which gives us 0. If you divide 0 with any certain number, the result is 0. So that P can be 0, but Q must not be equal to 0. So these are all the numbers, so on, etc. or comes under what? Set of rational numbers. So we can take either negative or positive. Not only these two numbers, we can also take 7 by 5. Not only proper fractions, even improper fraction also comes under rational numbers. Let us discuss some properties of rational numbers, in which first one is closure property under the operation addition. Here, let a and b are any two rational numbers, then if a plus b is also a rational number, then the set of rationals is closed under the operation. What is the operation considered here? Under the addition. Okay. So see that, for example, 2 by 3 comma 3 by 5 both are belongs to rational numbers. Then 2 by 3 plus 3 by 5 is also belongs to rational numbers. Two individual rational numbers are considered. If their summation also rational number, then this property is known as what? Closure property. Set of rational numbers comes under what? Closure under the operation addition, right? So if the summation is not a rational number, then it is not considered what? Not a closure. But if you consider any two rational numbers and check it, their summation ultimately belongs to or became the result of two summation or two numbers whose sum also always comes under rational. Therefore, set of rational numbers is set to what? Closure under the operation addition. What is associative property under addition? Let us see that. Let a comma b comma c belongs to rational numbers. That means a, b, c are any three real rational numbers. Then if this condition is satisfied, that is a plus b plus c is equal to a plus b plus c. If LHS is equal to this RHS, then this property is known as what? Associative property. If you consider any three rational numbers and those numbers, if they can satisfy this condition, that is here in this case b associated with c, but whereas b associated with a, even though if the result is same, right? Then this property is called what? Associative property. Under what operation is applied here? Addition. Therefore, this property is known as associative property under addition. Okay. See that, for example, let a is equal to 3, b is equal to 4, c is equal to 5. Now you can write this as 3 plus of 4 plus 5, which is equal to 3 plus of 4 plus 5, right? So now what can you check here? 3 plus, first add the bracket value, that is 4 plus 5 is 9, then add to 3. Therefore, 3 plus 4 is 7 plus 5, 9 plus 3 is 12, which is equal to 7 plus 5, that is also 12. Whereas LHS is equal to RHS, therefore, set of rationals is associative under addition. We can conclude that associative property holds good by set of rational numbers under the operation addition. Another important property, that is commutative property under addition. Let a and b are any two rational numbers, then if a plus b is equal to b plus a, then a and b are set to what? Commutative under addition, right? For example, let a is equal to 2 by 3 and b is equal to 4 by 6. Then add LHS you consider, that is a plus b, that is 2 by 3 plus 4 by 6. LCM is what? 6. Therefore, multiply numerator and denominator with 2 in order to get 6. 2 2s are 4 plus 4. So it gives us 8 by 6. So if you simplify this, we will get again 2 4s are 2 3s are. So what do you get here? 4 by 3. Now if you consider RHS, that is b plus a. What is b plus a here? 4 by 6 plus 2 by 3, right? So if you simplify this, it is also converted into simplest form. Directly you can do here itself. So 2 by 3 plus 2 by 3. What will get then? Same LCM. LCM is 3. 2 plus 2 is 4 by 3. In this case you are getting 4 by 3. Here also you are getting 4 by 3. Therefore 2 by 3 and b is equal to 5 by 6. And check the LHS. What you get? Here LHS is what? A plus b, right? A value, check it. 2 by 3 plus 5 by 6. If you write LCM, you will get a 6. Then according to 6, we should get a 3. 6 means we should multiply numerator and denominator with 2. Therefore, it will become 4 plus 5, which is equal to 9 by 6. By simplest form, if you write 3 by 2. 3 3s are 3 2s are. Next, RHS if you consider here, which is b plus a, that is 5 by 6 plus 2 by 3. LCM if you find, what you get here? 6 comma 3. LCM is 6. So in order to get 6, numerator multiply by 2, denominator also multiply by 2. Then it is 5. 2 2s are 4. So 9 by 6. If we cancel this, 3 2s are 3 3s are. So it gives us 3 by 2. right? What did you observe here? LHS is equal to RHS. Therefore, set of rationals is commutative under the operation what? Addition. So, what do you mean by identity? In order to find the additive identity in rational numbers, we should come to know that identity. Identity in the sense, we add any number to a given number. The given number itself it to be obtained. For example, 5 is there. For 5, which number if we add here, the same number 5 to be exist as a result, as the sum. What is the number to be added here? 5 plus 0. So, when you add 5 plus 0, it gives us 5 same as identical number. Then the number which is added is called additive identity. Therefore, additive identity is 0 exists in rational numbers or not? 0 also part of rational numbers. Therefore, additive identity is what? 0 is the additive identity in the set of rational numbers. Not only for 5. For example, if you consider any rational number which is in the form of p by q, that is 5 by 6, if you add 0 to this number, it gives us what? 5 by 6. Okay, or otherwise we can also write as 0 plus 5 by 6. To any number if you add 0 also, you'll get the result as 5 by 6. Or to 0 if you add any number also, the number itself will be existed. Therefore, 0 is set to what? Additive identity in the set of rational numbers. Now we are going to find a closure property under multiplication. Let us see the definition of closure property. Let A and B belongs to set of rational numbers, and if A into B also belongs to set of rationals, then this property is known as closure property under multiplication. For example, 2 by 3 comma 5 by 7 both are belongs to rational numbers. Let us multiply them. 2 by 3 into 5 by 7, which is equal to 2 5s are 10, 7 3s are 21. This 10 by 21 also belongs to set of rationals. Therefore, these two comes under closed under rationals. The given two rational number whose product also rational, then this property is known as what? Closure property under the operation what? Multiplication. When we are going to multiply, the result also obtained is belongs to set of rationals. Therefore, this property is known as closure property under multiplication. Now, let us discuss about associative property under multiplication. Let A comma B comma C, which are belongs to rational numbers, then if these numbers satisfy the condition of A into B into C, which is equal to A into B into C. This property if they satisfy, then A, B, C are comes under what? Associative under the operation multiplication. For example, A values B value. Let A is equal to 2 by 3 and B is equal to 4 by 3 and C is equal to 5 by 3. Then let us multiply and check it whether we'll get the same result or not. 2 by 3 into 4 by 3 into 5 by 3. So what you are going to get in this case? 2 by 3. Let us multiply the bracket value first. 5 4s are 20 by 3 is 9. Here also 2 4s are 8 by 9 into 5 by 3. Now 22s are 40 by 9 3s are 27, which is equal to 8 5s are 40 by 9 3s are 27. Here if you observe, LHS is equal to RHS, hence the given condition is satisfied, so that set of rationals is what? Associative under the operation what? Multiplication. Let us discuss commutative property under multiplication. Here let A comma B belongs to set of rational numbers, and if A into B which is equal to B into A, then set of rationals are comes under commutative under the operation multiplication. For example, in the place of A, you can consider 2 by 3 and 5 by 3. Now multiply and check it. So A into B. What is A into B here? 2 by 3 into 5 by 3. Is it equal to 5 by 3 into 2 by 3 or not? We need to check. A into B equal to B into A. Whether this condition satisfies or not, let us multiply. 2 5s are 10, 3 3s are 9, 5 2s are 10, 3 3s are 9. So LHS is equal to here RHS. What did you observe from here? So set of rationals, these are what? Commutative under the operation what? Multiplication. Let us discuss about a multiplicative identity, right? In the set of rational numbers, 0 is the additive identity, whereas 1 is called as, 1 is the multiplicative identity. Let us see the reason behind this. Consider some examples. Suppose if you multiply any number with 1, 2 by 3 into 1. So multiply numerator and this. What do you get here? 2 by 3 again. So when you multiply certain number with 1, the same number is existed as identical. Therefore 1 is called what? Multiplicative identity in the set of rational numbers. In the set of rational numbers. Is 1 exist or not in the set of rational numbers? So 1 also, the number exists in the set of rational numbers. That's what 1 we treated as a multiplicative identity. Next one, last but not least, that is multiplicative inverse. What is the multiplicative inverse of any given number? Multiplicative inverse. So how to find the multiplicative inverse of a number? Generally, if you consider 2 by 3, what is its inverse? Inverse is nothing but what? Reciprocal of the given number. Suppose if A is any number which belongs to set of rationals, then 1 by A is called as its multiplicative inverse. Here in this case, A must not be equal to 0. Why? Because if A is 0, then 1 by 0 is undefined. Except to 0, for every rational number there exists a multiplicative inverse. For example, 2 by 3 is a rational number which belongs to set of rationals. Then what is its multiplicative inverse? That is 3 by 2. It's a reciprocal. What is reciprocal? Numerator into denominator, denominator into numerator, interchange number. The numbers so formed by interchanging the numerator and denominator is called reciprocal. When you multiply with its reciprocal, it gives the value as 1. 2 and 2 gets cancelled. Finally, the value is 1. 1 is what here? Multiplicative identity. When you multiply both the numbers, if you get as a multiplicative identity, then each number of these is called multiplicative inverse of the given number, right? So 2 by 3 belongs to multiplicative inverse of 2 by 3 is 3 by 2. Here, let A comma B comma C belongs to rational numbers. Then A into B plus C, which is equal to A into B plus of A into C. Here A is distributing among the two terms, that is B and C. A, B, C are the rational numbers. Here if A is splitted or distributed among the bracket values as A into B plus A into C, then this distributive law is called left distributive law. Left distributive law or left distributive property. In the same manner, we can also multiply on right side as like this. Then this property is called B into A is nothing but B into A plus C into A. So that is called, if it is right side multiply, then it is called right distributive law. So distributive laws are two types. Anytime the quantity is multiplied either left side or right side, here multiplication is splitting over addition. So this is called what? Distributive property over addition, right? You can see that very simple. Just A is splitting for the terms of which lies in the bracket. B into A plus C into A. Here you can observe this.